You've probably heard Billie Eilish's song about it, but what actually is a supernova? Hi, I'm here with Minute Earth. A supernova occurs when all of the hydrogen in the core of a huge star is transformed to iron and explodes. Well, not exactly. Stars come in a huge range of masses. And when they die, they do so in a variety of ways. Stars with relatively low mass die pretty slowly, but those with relatively large mass die in a sudden explosion, a supernova. This explosion is one of the most energetic events in the universe. The sudden flash of light can then be followed by several weeks of extremely bright light, perhaps as much light as 20 million stars. When scientists observe a supernova in another galaxy, they can measure how long it takes for the light to reach us and thus calculate the distance to that galaxy. Because supernovae are so bright, they can be seen from incredibly far away, and they serve as standard candles for measuring cosmic distances. However, these explosions aren't very common. They occur about once every 100 years in any galaxy, and in 1987, a supernova that could be seen by the naked eye occurred in the Magellan Cloud, a galaxy close to the Milky Way. That's the closest supernova we've seen since 1604. And in fact, no supernovae have occurred in the Milky Way since 1604. But there was one very impressive supernova in the Milky Way on July 4, 1054. There was a great explosion followed by 3 months of lighted skies, and historical chronicles of the time were full of accounts and unusual explanations for the misunderstood phenomenon. Many people believed that it meant that the world was coming to an end. But the star stuff happens in 2 stages. First, a star shines steadily as its core hydrogen is converted into helium through nuclear fusion. Second, the core contracts while the outer layers expand dramatically. Then when the core reaches the iron peak element on the periodic table, further fusion is no longer possible. Scientists think this second stage may cause the explosion of a supernova, but exactly how this happens isn't completely understood. What happens in a supernova explosion is complicated. In a nutshell, though, the core contracts until it becomes so dense that protons and electrons are forced together to form neutrons and a neutral particle. Iron builds up in the core, and as it grows, the star can no longer support itself against gravity. When the iron core reaches about 1.4 times the mass of the Sun, it collapses in a fraction of a second to just a few kilometers across. The implosion ejects the outer layer of the star at high speed. As the core rebounds, this material is thrown into space at half the speed of light. A shock wave is sent out into the surrounding stellar material, which glows as it is heated and expands. The light from this explosion is what we see as a supernova. If the initial mass of the star is more than 30 or 40 times the mass of the Sun, the core is likely to continue collapsing until it reaches a radius of about 10 kilometers. At this point, the core is so dense that not even light can escape collapsing it. Further collapse continues until a black hole is formed. If the star had less than about 30 or 40 times the mass of the Sun initially, the core rebounds after collapsing, leaving behind a neutron star, a small but extremely dense object composed of neutrons. Both neutron stars and black holes are called compact remnants because they are the collapsed cores of giant stars. Supernovae were first officially recorded in 1054 AD, when Chinese astronomers documented a guest star in the constellation Taurus. It shone so brightly that it could be seen during the day. Japanese, Korean, and Islamic astronomers also recorded the event, but Western astronomers did not record it because at the time, the Dark Ages were in full swing and scientific observation had yet to be revived. Since then, about 15 supernovae have been observed within our galaxy, and many of them have been incorporated into constellations. For example, the brightest star in the small Magellanic Cloud is designated as a supernova remnant because it is the exploded core of a star that went supernova in 1604. Another famous supernova remnant is Cassiopeia A, visible in the constellation Cassiopeia. Its light is still being powered by the explosion of a star that went supernova in 1611. In the year 1987, a supernova was observed in the Large Magellanic Cloud, and that's the closest one we've seen since 1604. It was given the designation SN 1987A. And because it was so bright, it could be studied with powerful telescopes on Earth and in space. At first, the supernova appeared to be fading, but then it brightened again. Astronomers now believe this happened because dust in the surrounding gas and dust absorbed some of the light. After 5 years, the brightness began to fade again, and it's still going on. Since 1993, several dozen supernovae have been discovered each year. Most of them are found in distant galaxies. Some have been used to help map the expansion of the universe. In recent years, though, astronomers have begun to identify supernovae in nearby galaxies that can be studied in great detail. Supernovae are important because they enrich space with heavy elements such as iron, gold, and uranium. These elements are produced inside massive stars during their normal operation and are released into the universe during supernova explosions. This enrichment is important because the solar system formed from a cloud of gas that was enriched by earlier supernovae. Without these explosions, the universe would not contain enough heavy elements for life to flourish. To learn more about supernovae, check out the links in the description below. Thanks for watching this episode, which was brought to you with the help of our patrons. If you'd like to help us make more videos like this, visit our page or click the join button in this video. You'll get access to a bunch of cool perks, like blooper reels, a patron-exclusive podcast, and the power to request topics for future videos.